Lesson 16.1, Task 1. Graph sine and cosine functions. All right, so to graph the basic sine and cosine functions, we're going to remember that in the previous module you learned that the coordinates x and y of any point on the unit circle are given by your cosine of theta and your sine of theta, as shown. So when we were looking at angles, this was our initial side, this is our terminal side, and when you have this angle measure here, we use the symbol theta for these, and then so the cosine, comma, sine, this is our x and y coordinates, okay? All right, so the table shows several values for the function. F of theta equals sine of theta. All right, so theta is like our x, and f of x is like our y. So these are our x and y values, and we're looking at just values for the sine function, okay? So for each of these values in the unit circle, this is just the table of values that you would find if you went through and figured out what each of those were, given your 30, 60, 90, and your 45, 45, 90 triangles like we did before. Okay, so when we're looking at these, we are looking at the unit circle again. As you can see, the radius here is 1 unit. So that's where that table of values comes from. All right, so it says look at the unit circle and the values in the table. What appears to be the domain of f of x equals the sine function. All right, so what's going to happen is you're going to start and it's going to go, but you can continue to go around and around. Also, if you go the other direction, it's going to go negative, but you can continue to do that as well. So your domain is going left and right infinitely, so it would be all real numbers. Now, the table does not show all real numbers because this is just a few values based on one rotation of 0 to 2 pi. But as you remember, when we were looking at angle measures, you can go counterclockwise, which is your positive angle, or you can go clockwise, which is a negative angle measure, and you can rotate more than one time around. So that tells us that our domain would be all real numbers. All right, so what appears to be the range? All right, so the range is your y values. So that's your f of theta. So it goes from 0 to a half, 1, a half, 0, negative a half, negative 1, negative a half, back to 0. So this one is going to bounce back and forth between negative 1 and 1. So your range appears to be from negative 1 to 1. All right, select all values that are x intercepts of f of theta equals sine of theta. All right, so remember your x intercepts can be located when your y is 0. When y is 0, that means your x is crossing, or it means it's crossing the x-axis at that point. So we've got 0, pi, and 2 pi would be our x intercepts. So 0, pi, and 2 pi. All right, so it says, what is the y-intercept? Okay, so then you look at the y-intercept. The only one, it would be crossing at 0. All right. How can you use the unit circle, the table, and your knowledge of coterminal angles to describe the value of f of theta equals sine of theta over the domain of 2 pi to 4 pi and over the domain negative pi to 0? All right, so remember coterminal angles just means they have the same terminal side, but they're 2 pi rotation away, which means they're one complete rotation away, either forward, which would be this way, or backwards, which would be the negative direction. So how can you use the unit circle to describe the values of the domain? So add 2 pi to each value of the function, multiply each value of the function by 2 pi, or the values of 2 pi to 4 pi and negative 2 pi to 0 will repeat the values from 0 to 2 pi. So this is your best answer, because whatever is going to happen between 0 to 2 pi, if you continue, it's going to continue as well. So it's going to be kind of repeats. It's going to repeat every time you go around the unit circle. So every time you do a rotation of 2 pi, whatever those values are, if you do another rotation of 2 pi, it would repeat that. All right, so the graph shows f of theta equals sine of theta for negative 2 pi to 4 pi. Use the graph to identify the domain, the range, the max, the min, the intercepts, at least one interval each of increase and decrease in behavior, and whether the sine function is an even or an odd function. All right, so the domain, we've determined that the sine and the cosine will have a domain of all real numbers. And the range is how far up and down it goes. You can see that it goes from negative 1 to 1, and it kind of goes back and forth. But you also can see the domain will continue. And even though it stops here, you could continue on and on. So that's why this is all real numbers. So the range is negative 1 to 1. The maximum value, you can see the maximum value is going to top out at 1. And if you come down here and look, that's at pi over 2. So at pi over 2. And then every time it goes around the complete circle and comes back to that. So this 2 pi n just means how many rotations around back to that. All right, your minimum value comes from negative 1, and that negative 1 comes from 3 pi over 2 plus however many rotations. So 3 pi over 2 represents this specific minimum, but then if you come over here to this minimum, this would be 2 pi n away from this one. So it's just one rotation away. So that's what this indicates right here. And then negative 1, again, is your lowest point. That's your y value or your minimum. All right, so then it says the function is increasing on. Increasing, remember, goes from left to right. It's going uphill. And decreasing means from left to right, it's going downhill. So the function is increasing on negative pi over 2 to pi over 2. So we're going from here to here. On our x values, it is increasing. And the function is decreasing from pi over 2 to 3 pi over 2. The function value is blank as theta increases and decreases without bound. All right, so they isolate between 1 and negative 1. As you see, like it bounces back and forth, consistently going between 1 and negative 1. So those values are kind of isolated between 1 and negative 1. All right, so the function is, all right, so this function is odd. So remember that an even function is symmetrical about the y-axis. All right, so this is not symmetrical about the y-axis. If you reflect this over the y, this top hump here is not going to reflect that. So this is an odd function, which means it's symmetrical about the origin. So if you reflect here, this would reflect across, and that would produce an odd function. All right, that's all for task 1. If you have any questions, let me know. Lesson 16.1, task 2. So we're still graphing basic sine and cosine functions, and the table shows several values for the function g of theta equals cosine of theta. All right, so a minute ago we were looking at sine of theta. Now we're going to look at cosine of theta. So you can see some of the values, we're looking at the same units that we looked at from before, from 0 to 2 pi, and these are just different angle measures and where they hit. So you can see that the zeros, the X intercepts and the Y intercept are different, but a lot of the same things are going to occur. So just some similarities we're going to look at of cosine versus sine. So it says look at the unit circle and the values in the table, what appears to be the domain. So again, the domain's going to be all real numbers because we can continue to go multiple rounds and we can go in both directions, basically left and right, forever. So that's going to be all real numbers. And it says what appears to be the range. So again, the range is bouncing back and forth between -1 and 1. So -1 to 1 would be the range. And it says select all values of X intercepts. All right, so remember with sine we had 3 X intercepts from 0 to 2 pi. This time we're going to have 2. So we're going to have pi over 2 and 3/2 pi. So pi over 2 and 3/2 pi. So the x-intercepts you can see are opposite of the sine function. All right, so it says what is the y-intercept of g of theta for cosine? All right, so it's still going to be 0. Actually, no, sorry. The y-intercept, it intercepts at 1. All right, so how can you use the unit circle, the table, and your knowledge of coterminal angles to describe the values of g of theta equals cosine of theta over the domain 2 pi to 4 pi and -2 pi to 0? All right, so add 2 pi, multiply by 2 pi, the values will repeat values from 0 to 2 pi. So again, they're going to repeat the same values when you go around the rotation again in either direction. This would be counterclockwise and this would be clockwise. All right, it says the graph shows g of theta equals cosine of theta from -2 pi to 4 pi. Use the graph to identify the domain, range, max, min, intercepts, and at least one interval each of increase and decrease in behavior and whether the cosine function is even or odd. All right, so again, we can see that it continues in both directions, left and right, forever. So this would be your horizontal is your domain, your x-axis. So we're going to say all real numbers. Our range, again, is from our highest to our lowest point, and that would be -1 to 1. Our maximum value here hits at 1. And it would be at every rotation of 1. So every time you go from 0 to 2 pi to 4 pi, each one of those. So we have to do 0 plus or minus a rotation when it goes up to 1. Your minimum is going to go to -1. And again, it's going to be on every rotation of pi. So pi plus each 360 degrees. Remember, 2 pi is just another version of 360. So you've got radian measure and degree measure, and 2 pi is radian measure for 360 degrees. All right, so the function is increasing on. Again, we're looking going from left to right. So either from pi to 2 pi or -pi to 1. So it's going from pi to 2 pi. You can see from here's the lowest point is pi, and then increasing up to 2 pi. And the function is decreasing from 0 to pi. And the function values as theta increases or decreases without bound. So again, they're going to isolate between -1 and 1. All right, so it's talking about the end behavior. So it's not really going off in any direction forever. It's just going to isolate between -1 and 1. And this function, if you look here, this is the y-axis. If you reflect this across to y, that would be a direct reflection there. So this would be an even function. Where the sine function was odd, the cosine is even. All right, that's all for task 2. If you have any questions, let me know.